The clouds that are in our atmosphere now are not the same ones as hundreds of years ago before industries really started to develop. As we as humans put more and more particles into the atmosphere, we're making more and more sites on which clouds form. It's changing the precipitation of the planet.
Thanks for joining us on Today I Learned Climate, where you learn about climate change from real scientists. I'm Laur Hesse Fisher from the MIT Environmental Solutions Initiative. In our last episode, we spoke about condensation trails, better known as contrails, those lines that look like clouds that trail behind airplanes, and how they actually warm the planet. But what about natural clouds? Do they warm the planet too? What do they have to do with climate change? To help us better understand this, I spoke with a clouds expert at MIT's Earth, Atmospheric, and Planetary Sciences Department.
My name is Dan Cziczo. I'm an atmospheric chemist. I have a joint appointment in civil and environmental engineering, and I've been at MIT for 8 years now.
Professor Cziczo studies how humans have changed the composition of clouds and what that means for our planet. Yeah, you heard me correctly. Human activity has changed clouds. That is a crazy concept. Professor Cziczo has been studying this since the 1990s.
As part of my PhD, we started looking at the impact that humans could have on particulate matter, on clouds in the atmosphere, and how that might participate in our understanding of climate.
Particulate matter is going to be really important in this episode. It's important to understanding how clouds form and how they work. So basically, particulate matter is the collection of extremely small particles in our air and our atmosphere.
You might think of that dirty truck that's in front of you on your way into work and it's belching smoke out. So that would be a type of human particulate matter, or what we would call anthropogenic particulate matter. And of course, there's also natural sources for the particles that are always around us.
That's like sea salt, dust from dust storms, ash from fires. These are all examples of particulate matter that occurs naturally.
And so our environment, the environment around us, is always this complex mixture of natural particles and human-made particles. And so we think about dust storms as being something natural that's always happened. And that's true. But we've also pulled up ecosystems, grasslands, and turned them into grazelands or into farmland. And so when the wind comes by, dirt, soil that would have otherwise been held by those root systems of those plants aren't there anymore because of human activities. And so as humans, what we've actually done is we've unintentionally increased the amount of these natural particles in the world.
So there's this natural particulate matter that's just a normal part of the Earth's, cycle. And there's more of it because of human activity. And there are other unnatural particles, like from car exhaust, that we've added that's never been there before. Okay, so what does this have to do with clouds?
They don't just sort of form out of water vapor. They actually condense on a little particle. And so as we, as humans, put more and more particles into the atmosphere, we're making more and more sites on which clouds form. Well, what does that mean? It means that each one of the droplets that forms on all of those new particles is only going to be about half as large. So they're not going to weigh as much. That means they're not going to start raining as quickly.
What makes this even more interesting and even more complicated to study is that some particles are better at forming clouds than others are. And some particles are better at making the ice crystals that become snow. And some create clouds that reflect more light than others. And these particles all interact with each other and their environment. So they behave differently depending on what other kinds of particles are around, and also what the climate is like where you are.
So, you might put that one particle that we're talking about in the air around Boston, and it might have one effect. But if you put it around, we were talking about Los Angeles, it might have a completely different effect because the temperature is different, the relative humidity is different, the environment around it is different. Then we could take that, specific particle that we're talking about and put it in another location around the planet, over the poles or over the equator, and it's going to act completely differently.
The reason why this is so important is because this is what Professor Cziczo and other scientists and engineers need to know to understand how these particles impact rainfall.
One of those complicated factors that we're sort of trying to tease out right now is, where are we going to see less rainfall? Where are we going to see more rainfall? Where are we going to see more snowfall? Where are we going to see less snowfall, and so on?
So how do you even study that? Are you actually looking at the composition of the atmosphere, or you have, I don't know, labs where you're recreating artificial environments?
Yeah, both of those things, actually. Okay. We do two types of studies. One is we make clouds, and the other one is that we find clouds. And so we have a couple strategies of doing that. Probably the most fun is that we get on research aircraft, and they belong to folks like NASA or NOAA or the Department of Energy. And we put our instruments on them. We try to go out. We try to sweep up those droplets and ice crystals, and then figure out what the particles are that are inside. And so once we've done that, then we go back to the laboratory, and we have a series of cloud chambers in our lab where we can manipulate temperature and relative humidity in a very controlled way, and then be able to figure out, like, if we tweak particles in the future, if human industry acts differently, how is that going to affect climate?
But there's something else at play here. In our last episode, we talked about how contrails warm the planet because they absorb more heat than they reflect. For those who missed that episode, here's a 10-second summary. Contrails absorb heat radiating off of the Earth, like how a jacket keeps in your body heat. And at the same time, it also acts like a shade, reflecting the sunlight that would have normally warmed the Earth. So the question is, do real clouds act the same way?
Oh, that's a great question. So contrails are a fascinating topic, and they're very unique in the sense that they actually warm climate. They're one of the few clouds that net warms climate as opposed to cooling it. And so what's the reason for that? It's because they tend to be very high in the atmosphere. They tend to be so high up that the amount of sunlight that they reflect back into space, the cooling effect that they have, is actually overwhelmed by the amount of heat that's trying to make it off of the surface of the planet that they trap.
Okay, so because contrails are so high, they act more like a jacket than like a shade. But the real clouds floating below cool the planet because they're able to reflect much more light and provide more shade. Okay, but wait a minute. If clouds help cool the planet, then couldn't that help with reducing global warming?
Oh boy, I think we might need 2 or 3 more hours of podcast to talk about this. When I say that particles and clouds cause some amount of cooling that's less than the warming we've experienced, it won't be a huge leap for people to say, well, if particles and clouds create a little bit of cooling, why don't we put more particles in or make more clouds, and then we can offset all of that warming. Unfortunately, for those people that are thinking about that, I don't want to burst your bubble, but somebody has already thought of that. And it's a topic that is often called geoengineering. And so this is the idea of manipulating the climate of the planet around us for an end result, ultimately, trying to keep the temperature close to what it is now or what it has been in the past. There's a whole number of side effects that go along with those. And some of those side effects are as bad or worse than the temperature changes that we're seeing in the planet around us. And so if we were to actually try to augment or increase the amount of particles, we might have adverse effects on the health of people.
And on coral reefs and marine life, which are hurt by increased CO2 no matter how much sunlight is coming in. That's another episode we'll have to do.
And so the quote-unquote solution might not be as bad as even the problem. And I'm not sure that folks would want to make that trade. The truth of the matter is that we, as scientists, have for over 100 years now understood the impact that greenhouse gases are going to have around the planet. This was not a surprise. This was nothing new. As scientists, we knew that this was a real situation and something that was coming for a long period of time. There's really no question in that or what's going to happen moving into the future. But the one thing that I would like to get across to folks is that there is some uncertainty in that. So is the planet going to be 1 degree warmer or 3 degrees warmer? Those are very different planets moving into the future. And so bear with us while we're trying to figure that out. We're not going to give you false information, but what we're going to try to do is be as upfront as possible about what the range of possibilities of the future are, and how we might adapt to that moving into that future.
So while scientists are clear that human-caused climate change is happening, they're still trying to figure out how fast this is going to happen and what the impacts are going to be. And the question about what we do now, which future we prepare for, given the range of possible futures that we might experience because of climate change, well, that's not up to science. It's up to us.
we as scientists are highly certain that the temperature of the planet has risen and will continue to rise. The amount that it rises is very secondary to the fact that it is rising. Uncertainty is not a call for inaction. The less CO2, the less greenhouse gases that we all can produce on an individual level as well as a societal level is really important right now. So, the choices that we're going to make now are going to have ramifications for the next generation, the generation after that, really hundreds and even 1,000 years into the future. And so it's something that we have to start having a frank discussion about, not just sort of reading, the catastrophic news articles and things like that, but really thinking about what we're going to do about energy usage moving into the future. What world we want to leave the next generation to inherit.
So what can you do as an individual? Well, there's a lot, but one of the reasons that we created this podcast series is because we wanted to help you better understand what's going on with climate science and climate change and how it all works, so that you can better share and open up conversations with other people. So share this podcast with someone in your life. Share with them something that you learned about climate change because of this. We hope that will help open up a conversation so that we can have these frank discussions about what we can collectively do. I want to thank Professor Dan Cziczo for speaking with me, and to you for tuning into Today I Learned Climate, brought to you by the MIT Environmental Solutions Initiative. You can find other Climate Change 101s on our website, tilclimate.mit.edu. That's tilclimate.mit.edu. What do you want to know about climate change and how it will affect us? Do you still have a lingering question from one of our episodes? Let us know by tweeting #TILClimate, that's TILClimate, or sending an email to climate@mit.edu. Thanks so much, and see you next time.